Hello everyone, welcome to our video. Today I Cadet Mahing Singh, who is initiating this idea.
And I Cadet Narendra Pakhala is a supporter of this idea from Second School Imphal.
We are going to explain our project, that is laser pointing distance measuring tool. Our project is not a simple project just for namesake, but it is a very common solution for a very basic difficulties faced by today's student. As we have seen in daily life of student, when a student needed to measure any kind of distance, let's suppose for their project work or demonstration or a type of practical work, they are using just simple measuring tools such as scales and inch tape, which is a very inconvenient way. Since you have seen, while measuring the distance through scale and inch tape, you have come across many errors like human errors and kind of distraction it is there. So which will also decrease the accuracy of the results which we wanted, and also decrease the overall development of that particular project, practical work or demonstration whatsoever. So to improve this state and overcome this kind of problem, we have developed a simple but more precise tool, that is again laser pointing distance measuring tool. So here I am going to tell you some of the components and the functioning of the tool. Here we having a board where we have located our some components. Since I am going to explain you one by one, you have seen these two pairs. These two pairs are, one is laser module which is mounted on the shaft of rotary encoder, which is act as an angular sensor. The main function of this angular sensor means rotary encoder is to measure the angle, and we have adjusted these two things in such a way that whenever I move the laser, it will rotate the shaft of rotary encoder, which will give some reading of the angles. Our project is simply based on the concept of straight lines, angles and trigonometry. It is a basic, and using by basic component, it make it more simple and not very complex to understand. So what we are going to do is that, look here. Let's suppose there is an object here. It is an object, some kind of object. So I am striking the laser beam over there at some point. And now the work I have to do again is to align the laser beam or laser beam point on the object by another laser. So our work is to coincide the point, the common point on object by these two lasers. And when we are doing this, when we are aligning this laser, it will also rotate or give some reading to that angular sensor. We will sense the angles between the reference line, that is our x-axis. And before that, going about this functioning, I have to tell you that these two pairs means mounted laser and rotary encoder. These two pairs are differently placed at different points on a reference line on x-axis. Let's suppose it is placed at origin and it is at somewhere on the x-axis. Let's suppose c, 0. So by improving that, we can able to get the perpendicular distance of the object to this reference line by formulating a trigonometric formula which I have developed. Just we need the reading of the angular sensor, means the angle made by the aligned lasers.
Now I here will be explaining you the complex figure in this simple form with a nutshell. These two red arrows here are lasers of this device. They will be pointing at an object, and by merging those lasers at a common point on that object, we will get the perpendicular distance from the reference line from the object in milliseconds. Imagine a device with just two lasers pointing at an object that will give you the distance of it. This is our idea. Simple, isn't it?
And for further improvement, I have put a LCD here. Since student needs to record the results, so I have provided a LCD with a very great refresh rate. It will detect every single movement which is going on. It will detect the lasers, angle made by the lasers or pairs, and also the results. And now, for more reference, we are having our microcontroller as Arduino Uno, which will be compiling all this functioning with them, and some circuit will be there. So our work is to just manually handle the lasers in order to align it to a particular point on an object, the desired object, which distance I wanted to know. And the distance will automatically calculated and display on the LCD. And that distance would be the perpendicular distance I have told you from the reference line. It is a very good idea. Now coming back to our project, let's go for a simple demonstration. As it is our partial working prototype, since we don't have the lasers, but I am going to give you a simple demonstration how it's worked. As you are focusing on the LCD, you can see three variables over there, A, B and R. These are representing angles and results. A is the angle made by the first laser with the reference line, and B will be the angle which is measured by second pair or laser with the reference line. As you can see, when I am moving the shaft of the rotary encoder, these three are the rotary encoder, and this rotator is for contrast knob, as I am demonstrating. See, you can see some changes going on the screen. It is for contrast. So for this two angular sensor, when I am moving this, right, my right one means angle B, you can see some changes going over angle B, and when I am switching it, you can see some changes going on angle B, and it is also reflecting or also relating to the results of this LCD or our distance measuring tool. So our simple work is to, if you don't align the laser to a particular point, then you will not get the desired results. Is it showing the result? Because I have put it the formula. The formula is just need to calculate the angle and put it there. So as I am moving, calculating the angle, but it doesn't mean that it is going to give a correct distance if you're not able to align the point on the particular point of the object. So this is our simple demonstration, our explanation of our project. Our project is not helping the students in order to come up with this problem, that is measuring distances from a particular point with accuracy, but it is also helping the student understand what they wanted to do in their life. Since students are learning only the application or only the theoretical part of their life or their studies, but they are not applying them. But through that, they can get motivated and inspired. That's how the simple concept of straight lines, angles and trigonometry we will able to do and dominate over a particular problem. So this is a very nice idea, isn't it? So that's all for our video where we have explained everything. तेरी बारी